Hello friends, welcome to our channel. Every day I that is gave different. I am giving the different topics on computer organization. So today new topics I will explain, that is a tri-state buffer. A tri-state buffer, other name also, that is three-state buffer. Okay, that is a three-state buffer. How to design three-state buffer, or what is the tri-state buffer? Okay, three-state buffer or a tri-state buffer, it's a one kind of a gate which is a digital circuit that exhibits three states. Normally we discuss in previously, whenever we will provide any inputs to the any kind of a logic gates, then two states are normally we are providing, or one data will give, then it will provide, or that is one output. Okay, normally very convenient way we, that is a define different logical circuits or logic gates as our requirements. But here today I will discuss, that is a tri-state buffer, where two states are signals equivalent to logic 1 and 0 for conventional gate. Normally we will provide some inputs to the any circuits, obviously one output we can get it. But the another third state we will consider as a, that is a high impedance state that behaves as a open circuit. Okay, that means a logical gates or buffer gates we will create, known as, that is tri-state buffer gate, where it has three states. Two states considered as inputs, one is another is output. But previously what happens, whenever we will consider two states, normally normal inputs we will consider, another output we can get. Okay, but third state we will consider for the buffer gate as a tri-state. So third state consider as a high impedance. That means open is the circuit is open, or that behaves like a open circuit. That means output is disconnected. When third state we will consider, then that output is disconnected and doesn't have any logic significance. That means whatever inputs we will give to the circuit, that doesn't affect to the output. Okay, that is open circuit. That is whatever the data we will provide, that is open, that we can't get any kind of a output. Okay, this is the concept of a three-state buffer. Now I will show you how three-state buffer, the design of a simple design of a three-state buffer. Very simple way I will show you, then we can understand what is the three-state buffer is designed. Here already I designed, see, very simple things. Here is a three-state buffer. One state, you see, one state is a normal input we will provide here, normal input, and whenever we will provide normal input, then accordingly output we can get it. Okay, there is no problem, output we can get accordingly, because whatever the normal input we will provide, then output we can get it, by which we can tell as a here two state. But since we create, or our topic is a three-state buffer, another state we consider as a control state or control input state. You see here mentioned control input state. That means it control to these circuits. Either it will receive the input and get in the output, or whatever the input will provide to this circuit, there is no effect of the output. Okay, so by which it control this input. Okay, we can consider as a control input by C. Here mentioned, you see it is C, and a normal input will consider, that is A. Whenever provide any kind of input as A, any kind of input, doesn't matter, that is we can get Y output, here Y output, and it will control through control input, that is C. Now, what kind of data or what input we will provide to this circuit, by which what kind of data we can get it, what kind of information we can get it. You see, suppose output is equal to y is equal to a. Output y, here is y is the output, y is equal to a. That depend on a input, because normal input I have already mentioned, normal input a. That means whenever y output will get it, it depend on the what is the normal input. Okay, that means this input will pass to this circuit. Okay, then it will get output where the control input C is 1. You see here mentioned, you see C is 1, it is mentioned C is 1. That means whenever C is 1, then output y is equal to a, means a input assigned to y, or a input considered as a output for y. Okay, when C is equal to 1, if C is equal to this C, if 1, then normal input pass to the circuit and get the output. Okay, another case, normally you see that normally two kind of data we can consider. One is that is 0, another is 1. If it is 1, it's okay, no problem, that direct input data we can get it as output. If C is equal to 0, if C is equal to 0, okay, if C is equal to 0, then what happens, this circuit will be open. This circuit will be open. What are the input we will provide, there is no effect to the output. So, why the output will be disconnected to the circuit. Okay, because C is 0. C is 0, that is no effect of the input whenever we will get output. There is no output we can get it because circuit is open. This is the basic concept. So, that is for the reason this control input is very important for tried set, okay, or third state buffer. This is the basic concept of a third state buffer. Once again we tell, this is the one state, this is the another state, this is the one state, this is the second state, this is the another state, third state. So, these three state makes this buffer, that is a three state buffer, where this first input buffer or first input data or this first state having any input provide to the circuit, then we can get y output if C is equal to 1. If C is equal to 0, then there is no output we can get it, because output that is disconnected, okay, from this circuit. So, for the reason we can tell as it is a open circuit. Okay, if C is 0, there is a open circuit, we can't get it output. In that case, we can tell as it is a high impedance. If it is C is equal to 0, you see it is mentioned C is equal to 0, it is a high impedance. Okay, that means circuit having no output. Whatever the input we will provide, there is no output. It is disconnected to the output. Okay, this is the basic concept of a tri-state buffer or three-state buffer. But whenever we design this three-state buffer or tri-state buffer, its application also very useful. Okay, we can also apply this tri-state buffer in another way. Okay, now we see how it will be applied. This tri-state buffer. Still, that is other concept also there. I will also explain to you. Okay, so you see previous that is three-state buffer. Whenever we will design, some condition we have to apply. That means what kind of conditions we apply for this tri-state buffer. You see, first condition, that is control inputs. Okay, I already mentioned that is some control inputs is there. Control inputs, you see, control inputs determines output state. Okay, I have already told, because if C is equal to 1, then output is enabled as a conventional buffer, and output or normal input considered as a output. If C is equal to 1, this is the first condition for tri-state buffer. If other case, if C is equal to 1, it's okay. If C is equal to 0, then what happens? Output is disabled. Output cannot be considered disabled. And gate goes to high impedance, that holds buffer gate is a high impedance state to, and it avoid any normal input value. It doesn't receive any input value or doesn't provide any output whatever the input value is given. These two conditions applied for this that is a tri-state buffer. This is the basic concept. I explained how to design three-state buffer or tri-state buffer and what are the conditions. Okay, these two things we have to remember. Now I will apply this tri-state buffer in that is a bus structure, and how it is defined or how it is designed bus system using three-state buffer and decoder. Because before that is bus structure defined with multiplexers and registers, but here we consider that is how to design bus system using three-state buffer and decoders instead of multiplexers. Okay, register will consider, but instead of multiplexers, how it will design. Okay, this is the one thing. Another concept also I will show you. I will explain. Then you can understand how it is. It will be defined for of tri-state buffer. Okay, one small application we will consider through that is a tri-state buffer. So very simple way. After that another application we will consider. Now we see that is how use the that is tri-state buffer for bus line. Okay, that is a common bus line with the tri-state buffer. How we will design? Very simple way. I will show you. You see the common bus system or bus line using decoder and a tri-state buffer. Okay, very simple way I will design. See here, since it is considered decoder, we will consider also decoder and a tri-state buffer. So I will show you how. Let one decoder we will consider here. Very simple way. One decoder, that is a decoder consider, that is 2-4 decoder. Okay, 2-4 decoder here we consider. Okay, and these 2-4 decoder connect to that is a tri-state tri-state or that is a tri-state buffer in different ways. You see, very simple way I will show you. Suppose this one, this is a another, suppose here that is a B, here also that is a C, here also we can consider that is a D. Okay, so for that is inputs, normal inputs we can consider A, B, C, D, and one decoder will consider, and is having one output, and each output also connect to here, here connect to here, here also connect to here. Okay, so different connection here where different inputs we will provide to this buffer. But role of a decoder now we will see. Here decoder is that is a 2 into 4 decoder, because 2 inputs we will provide to this decoder and 4 output we can get it. These 2 inputs generated by, that is 2 selectors, that is S1, and we can just identify another way, that is S0, S1 and S0. Here we just consider 1, and here we can call select. Okay, S1, here S1 and S0. Another concept also we consider, that is a enable. Okay, here is a enable also we consider here. Okay, 3 that is inputs given to this decoder, and this decoder generate, that is 4 output. Okay, 0, 1, 2, 3, 4 output starting from 0, 1, 2, 3. Okay, and 3 output also connect to this. You see, very simply I will mention all output how it will connect. Okay, how it will connect. So this is the basic application of that is a tri-set. This is a tri-set because A, B, C, D are normal inputs will provide, and another state, that is data or inputs provided by this decoder. This decoder constructed by 2, 4 decoder, where 2 inputs will provide as S0, S1, and this will provide, that is 4 in outputs, which is considered as a input to this individual third state of this buffer. Okay, and whenever we will provide this data here, then automatically this A data consider as a input to this buffer and output in this way. Okay, and similarly B data consider as a input to this buffer, output considered in this way. C data, D data, like this. Okay, but the thing that how to define this one. Okay, how to define this one, which data will consider, that depend on this particular selector and enable. Selection designed through S0 and S1. Based on that, which data will be passed to this particular common bus, and we can write here is a bus line. We can tell as a bus line. Okay, bus line for bit or for data, any data, bit of data for data, bus line for data. Data is a collector from collection from or collected from A or B or C or D. Now how to choose this one, it depend on this selection. Okay, so here question is everything is connected, but how it will work? Okay, how it will work? For example, very simple, suppose we consider, that is a very simple way we can consider here. Suppose here S1 and S0, okay, S1 and S0, then the value can be considered as, we have already discussed, that is some truth table or functional table based on different selection. Okay, suppose here is 0, 0. Okay, 0, 0 means the output what from this decoder, output can consider as a 0. Normally, if it's 0, 1, it is 1, 1, 0, it is 2, 1, 1, it will be 3. This concept we have already discussed in previous classes or previous lectures. Okay, this is the basic concept. So, for example, suppose this particular 0, 1, here you see 0, 1. 0, 1 is S1 0, S0 1. So, which data will provide? This data will provide. Means you see 0, 1, 0, that is 0, 1 means 1. 1 data will this will be activate. Okay, this will be activate to this particular buffer. Then this buffer receive the data from B and transfer the data to this particular bus line. Okay, in that case what happens, suppose we will consider 0 1, B data will consider, and or B data, this particular data, this particular line or connection or this third state activate to this particular buffer. Then what happens, it will receive the this data, B data, and B data consider as input data, and that data consider as output data to this corresponding bus line. Okay, this will be passed through this bus line. Other will be here, other will be, if this is this data will activate, other will be, that is inactive. Okay, other will be inactive. So how this will be activate, or how this data will be activated, or which buffer will be activated, or which buffer receive the data either from A, B, C, D, depend on this particular 0 1 2 3. These are depend on these two selection or selector. Okay, S0 and S1, and this will be designed through this kind of a, that is a structure. Okay, this kind of table we can find out this data either 0 or the 0 for what, 1 for what, 2 for what, 3 for what, and which input data will provide to the corresponding buffer, and how it will release those data to the bus line. Okay, for example, this is 3. Okay, this data will this S0 is 1, S1 is 1, that is 3. 3 means this one means this connect to this buffer. So D data consider as input to this particular buffer, and other, and this data collect the data from this D inputs, and that data transfer to this bus. So if this data transfer to the bus line collect that data and use to the this data reach to the any kind of destination register. Okay, after that suppose it will reach the destination register, that is another part, but this data pass to this bus line. This is the basic concept. Okay, but here some question, everything is connected which that is register. These are the inputs, normal inputs. This is the normal inputs, we can tell as a normal inputs. These are the normal inputs. If these inputs will consider, then what happens, we can consider when enable E, whenever enable E, this E, enable E is equal to 1. Be careful. Whenever E is equal to 1, then we can choose S0, S1 data. According to that, we can choose either 0, 1, 2, 3. Based on that, which buffer we can choose. After that, it will receive which inputs from this number of inputs, and that inputs pass to this bus line. Instead, in case of E is equal to 0, for example, if enable is E is equal to 0, that means it will be disabled. If it is disabled, this decoder data will be totally disabled. Okay, if it is disabled, this, since it is considered as a third state buffer, third state will be disabled for this each individual buffer, tri-state buffer get. So automatically whatever the data will provide, that data cannot be considered. It will open circuit, it will be open circuit. So bus line having no data will be pass, because it is enable this disable this decoder. Okay, so if E is equal to 0, totally will be disabled. So there is no data passed to this individual tri-state buffer. So automatically it will be open circuit, automatically it will be open circuit. So this data, what are the data connected or data passed to this, so there is no effect to the output, and there is no data we can get from this bus line. This is the basic concept whenever we apply this tri-state for bus line or common bus using decoder and a tri-state buffer. Okay, it is a simple application, and another application is there. We will solve another problem, but we have to understand this particular application, how it will use. Okay, previous that another concept we have already discussed, that is how different parts we can define, how it is used, and how it will be, that is defined through this common that is tri-state buffer, how it is the basic logic, how three state will designed, and how different data is passed through that tri-state buffer. Actually normally it is two state, there is no problem. Whenever you use tri-state, it is a control inputs, and if that control inputs is 1, that is no problem, that inputs, normal inputs can consider as a output. If control inputs is 0, then automatically it will be create, that is a open circuits or high impedance, there is no effect of output. Okay, this is the basic concept. I hope all of you understand this basic concept of tri-state buffer. Okay, the next application I will show you in next lecture. Okay, thanks to all to watch this video. Thanks to all. If you like this video, please subscribe my channel and comments me to improve my this channel and this videos also. Okay, thank you very much. Thanks to all. Thanks.